Hi, this is deepsift. Deepsift extends protocol sift into an autonomous DFIR agent that is easier to trust. It's a model context protocol middleware layer that turns Claude into a zero hallucination DFIR analyst. Our core idea is simple. The model should never see raw command line output. Every one of our 155 type tools runs a real forensic binary, parses the result into structured JSON, tags it with MITR attack, enriches it with threat intel, and logs it to a tamper-evident chain of custody before a single byte reaches the LLM. We deliberately chose the hardest of the four architectures Sans offered, a purpose-built MCP server. There is no run shell tool. The agent physically cannot run a destructive command. Here's the structure. Claude Code makes only typed MCP calls, no generic shell. Each call drives a real forensic binary, Volatility, SleuthKit, istools, Plaso, Yara, and Hayabusa's 3700 Sigma rules. The raw output flows into a Python parser, then through MITRE automapping and a RAG knowledge base, and gets wrapped in a forensic knowledge envelope, caveats, advisories, and whatnot to conclude without corroboration. The structured result goes back to Claude. The full raw bytes go to disk under a SHA-256 audit record, and two guards, guard command and guard output path, block destructive binaries and any write to an evidence directory. They raise at the operating system level. That's an architectural guarantee, not a problem the model can talk its way past. For the live demo, we start with the Rogba case. deepsift begins with a normal first hypothesis. The intrusion may be visible in memory or network evidence. It checks the memory image, process list, and network artifacts first. But then it finds an important problem. The incident happened around November 13, while the memory image was captured around November 16. This is self-correction. deepsift does not force the first hypothesis to be true. The memory capture is about 3 days late. The process list does not show incident window process creation, and the network scan does not directly prove the attacker's session. So deepsift marks the memory first hypothesis as disproved. Then it pivots to the better evidence layer, disk artifacts. On disk, deepsift finds the actual attack story. Event logs show RDP brute force activity. LNK files and shellbags show SRL project files opened from a removable F drive. Browser history shows Google Drive and SharePoint activity, and recent artifacts show is delete-related counter-forensic intent. The important part is that each finding is tied to a tool result and an audit ID. A judge can trace the claim back to the exact evidence. deepsift also blocks unsupported claims. Here, a claim like mimikatz.exe is not present in the tool output. The grounding verifier marks it unverified and keeps it out of the final report. So the model is not allowed to win by sounding confident. It has to prove the claim. We also tested deepsift on other evidence types. On Vanco, both systems found the required answers, but deepsift went deeper. It correlated shellbacks, user assist, LNK files, jump list, USB history, and set up API logs. It also detected signs of USB registry wiping and reconstructed a 5-phase attack chain. On Nitroba, the evidence is PCAP based. deepsift extracted the HTTP post, recovered the message body, linked the Gmail cookie to the suspect identity, and added attribution caveats like open Wi-Fi and shared public IP. On AF case 2, the case involved encryption and anti-forensics. deepsift recovered the ACE password, BitLocker key, and GPG passphrase, while also finding PowerShell tampering and hidden VHD evidence. So this was tested across memory, disk, network traffic, and encrypted anti-forensics case. After the run, deepsift gives the examiner a review portal. It shows the verdict, timeline, MITRE mapping, hypothesis ledger, and claim level grounding. This is not just an AI-generated answer, it is a reviewable evidence package. Finally, we verify it. Preflight checks the environment, the tests pass, verify findings.py rechecks the saved findings against raw evidence and recomputes the audit chain. deepsift runs offline with no API key required. deepsift is auditable, autonomous forensics.